Third, the large-scale climate changes that come from the concentrations of greenhouse gases. Here, for example, is how global average surface temperatures have changed over the last century. The temperature record is much less smooth than the CO2 concentration record. You see warming to about 1940, then little change for a few decades, then warming that starts again in the late 70s, slowing down over the last decade. Why? Why does the temperature record look so bumpy when the CO2 concentration record that drives it looks so smooth? There are several reasons why the records look so different. First, because many factors push the climate one way or another. A big volcano, for example, puts sulfuric acid drops in the stratosphere that can cool the whole planet for a year or two. The same fossil fuels that put carbon in the atmosphere also pump out sulfur pollution and other fine particulates. These pollutants stay in the atmosphere for only a few weeks, but they can change the climate by reflecting more sunlight back to space. But unlike CO2 that accumulates slowly and spreads evenly across the globe, these pollutants have varied from decade to decade and place to place, as countries have changed the fuel they use, perhaps from coal to gas, and the environmental cleanup technologies they use, putting scrubbers on power plants or catalytic converters on cars. Second, the climate has lots of natural fluctuations, like the day-to-day variability of weather, that are random internal dynamics of the climate system, what physicists like me like to call noise. The net result is that we can be reasonably confident that much of the warming over the past half-century is due to human actions, and very confident that over the next century we will see a great deal of warming due to human action, but it's still very hard or outright impossible to know exactly what the climate will do from one decade to the next. This brings us to our fourth component, climate impacts, the many ways in which these large-scale climate changes influence human welfare and the natural world. Many important crops, such as rice or wheat, are damaged by high temperatures during the germination phase of their growing season. There's evidence that temperature changes we've already seen from global warming are cutting global crop productivity, perhaps by as much as 5%, compared to what it would have been had temperatures not increased, although the overall crop productivity has continued to rise as agricultural methods have improved. This is small as a global average, but by 2050, the impacts will likely be much worse. If we do not restrain carbon emissions and climate change over the next century, warming will accelerate the melting of the great ice sheets in Greenland and Antarctica, raising global sea levels. If we do not restrain emissions, sea levels might rise by a meter by the end of the century and several meters over the next few centuries. Climate change is not just warming. It tends to make the dry places drier and the wet places wetter. It increases the intensity of the most intense storms. It will create a host of other changes, small and large, from a dramatic decrease in the amount of Arctic sea ice to a loss of coral reefs driven by the acidifying effects of CO2 in ocean waters. This and all other predictions are subject to significant uncertainty. For example, with unrestrained emissions by the end of this century, sea level will likely rise anywhere from half a meter to a meter, but there's a good chance, perhaps 50% odds, that the rise will be outside that range. Many impacts, like rising sea levels, occur far in the future. Sea level rise is relatively small this century, for example, but it gets much bigger the next century if we can't stop it.